Hello everyone, today in this video we are going to talk about potentiometer. Potentiometer is a device to measure potential difference accurately, and it is often called an ideal voltmeter because it will measure potential difference with very less error. So this is a potentiometer. It has got a very long wire made out of manganese. So the wire is AB and it may vary from 400 centimeter to 1000 centimeter. And we have got one battery, we call it auxiliary cell or auxiliary battery, one rheostat to control the current through the potentiometer, and we have one voltmeter out here to measure the potential difference. And this is a scale through which we know the length of the wire, and this voltmeter is connected between A and J. This is a jockey which can slide over this wire. So this is all about the construction. This is the real picture of potentiometer, and this is the wire AB. Wire will start from here and it will take a round from here and it will go till B. It's a one single wire, and this is the board, and this is the scale and serials and rheostat and key. So voltmeter are not shown out here. Now working principle. Now this is a potentiometer. Now this potential difference between A and J can be given by V is equal to IR. I is the current flowing through the potentiometer and R is the resistance of the wire. And this R we can write as R is equal to rho L by A. Rho is resistivity, L is length, A is area. Now if you put the value of R, you will get this. Now in this equation, the current flowing through the potentiometer is constant, we are not changing it. The resistivity of the wire is not being changed, so this is also constant, and area is also constant. So only the thing we are changing is length. So other thing I can write it as constant. So V is equal to one constant into length. So because the length is being changed, so we can change the length. So length is not a constant, so V is equal to constant into length, or we can write V is proportional to length. And this is the working principle. Now if you change the length of the wire, the potential between A and J will also change. So this is the working principle for the potentiometer. Now we will draw graph between potential and length, and as we already know, potential is equal to constant into length, and this gives me potential is directly proportional to length. This is the principle of potentiometer. So for directly proportional, we have a straight line graph with a slope. If you increase the length, potential will also increase. And this K is V by L, and this constant is called potential gradient. Potential drop per unit length, and the unit of K is volt per meter. Now let's talk about the sensitivity of the potentiometer. The potentiometer is sensitive if it can measure small potential difference, and if the change in length is large for small change in potential difference. So suppose right now, for suppose 1.1 volt, suppose the jockey is out here. If you make 1.2 volt, it should show large deflection, means the point should come somewhere out here. So it should show large change in length for small change in potential, so that it can measure small potential difference also. And the ways to increase the sensitivity are, we can increase the length of the wire, or we can decrease the current through the potentiometer using the rheostat. Now we will talk about some facts about the potentiometer. So as we already know, it is used as an ideal voltmeter because the voltmeter cannot measure the potential difference accurately, because it has some resistance and some current will flow through the voltmeter, and due to that current it will not show the accurate potential difference. Voltmeter should have infinite resistance, but it will have finite resistance. due to which it cannot measure the current accurately. But the potentiometer works on null point method or zero deflection method, where the current is zero in the circuit, so that time it will not consume any current, so it measures the potential difference accurately. And alloys are used to make the wire of potentiometer because they have high resistivity and low temperature coefficient, due to which their resistance do not change with temperature. And copper cannot be used because they have low resistivity and they cannot measure the potential drop properly, because we know V is equal to IR and they have got very less resistance, so they cannot measure the change in potential difference, and their resistance will also change with temperature. And we should not send the current through the potentiometer for a long time. So as we all know, due to the heating effect, the wires will heat up and it will change the resistance, so we should not change the current for a long time. And the uses of potentiometer is, we can use it to compare the EMF of two cells, and we can measure the internal resistance of a cell.